Mr. Lucier's Chemistry Part 2. Alright guys, we got ionic compounds part 2. So we got the metal part done. Now we've got to name the non-metal part, right? Everything else, because it's always the metal and then everything else, okay? So let's go down right here. So now we're going to name the non-metal part, okay? Now, non-metals. There's two types of things you're going to see when you have non-metals. A regular non-metal, and you're going to see something new. They're called polyatomics, okay? I'm going to have to give you another example here in a second to go over polyatomics. Well, since this guy is a regular non-metal, non-metals take the "ide" ending, okay? Non-metals get the "ide" ending, okay? So what does that mean? So that means, let me come up here, all these non-metals get an "ide" ending. Boron becomes boride. Carbon becomes carbide. Nitrogen becomes nitride. Oxygen becomes oxide. Fluorine, fluoride. Chlorine, chloride. Bromine, bromide. Iodine, iodide. Sulfide, selenide, telluride. Phosphide, arsenide. So all you got to do is knock off a little bit of the ending of the main metal and put "ide" as the ending. So iron keeps his name. He's a transition metal. He gave a 3. So that's his iron 3. And chlorine becomes what, guys? He takes the "ide" ending. Chlorine becomes chloride. Okay? Chlorine becomes chloride. Now we're going to talk about polyatomics. Okay? Polyatomics, here I'm going to show you a list of polyatomics here. So those are your polyatomics, and as you see, there's many different polyatomics. So let me give you an example here. Let me give you iron again, and we're going to do sulfate, SO4, 3, okay? Let's look at this example here. This is going to be another example, okay? So as we see, remember I said it's always the metal and then everybody else, right? So here's the metal, and then here's everybody else. So if you see more than one element, like up here, if you see more than one element after the metal, that means it's a polyatomic. Is this a polyatomic? No, that's just chlorine, right? But you look right here, oh, we have the metal, but after the metal, we have more than one element. If you see more than one element after the metal, that means you're dealing with a polyatomic, okay? So I'm going to write that down right here. If you see more than one element after the metal, it's a polyatomic, okay? Cool part about polyatomics, guys, naming polyatomics are easy, because if you see a polyatomic, all you got to do is look it up on that list, that paper, because you'll see, oh, it's more than one. You're going to pull out that paper. Actually, it'll be on the computer, and you'll pull it up. You'll look for that polyatomic. You'll see its name, and all you got to do is write its name down. It keeps its name. Okay? Polyatomics always keep their name. So let's name this element right here. So this is a metal. I know it keeps its name. Who is Fe? Fe is right here in the middle. Fe is iron. So metals always keep their name. So I'm going to call this guy iron. Now I'm going to check, is Fe a transition metal? Right? You have to always check if the metal is a transition metal. Is Fe a transition metal? Yes, it is. So I need an oxidation number, right? I need an oxidation number. So we're going to go right here. We're going to look up the oxidation number. So what number do you think iron gave? Because look, This right here, this SO4, that is the polyatomic, right? This is the polyatomic. This is an oxidation number. That is an oxidation number. So when these guys swapped and dropped, let's undo the swap and drop so you can see exactly what's happening. We'll draw an arrow over here. Let's undo the swap and drop. We had Fe and SO4 trying to hook up, right? These are the two guys hooking up. Well, when we swapped and dropped, we switched numbers. I can see that this 2 was given to Fe. So I know that this sulfate is a -2. And this 3 was given to the sulfate, so I know that he is +3. I undo the swap and drop. I know metals are always pluses and nonmetals are always negatives, right? Pluses for the metals, negative for the nonmetals. So when these two guys hooked up, all they did was give each other the numbers, right? That's all they did. Oh, by the way, when you get more than one, they usually put the polyatomic in parentheses. But we'll talk about that later. So just know, if I undo the swap and drop, I can see what everybody's oxidation numbers is, right? So this tells me this is iron what? This would be iron 3. Okay? I undid the swap and drop happen. And when you look at the list of polyatomics, guys, you can see sulfate's -2 oxidation number. Here, I'm going to show you right here. Let's look at sulfate's oxidation number. And there you go. See? You can see that sulfate had this -2, so you know that 2 came from sulfate. That means this 3 over here came from the iron. Okay? Guys, remember SO4, look at it as one guy. Okay? So now, let's name, we got the iron 3, right? The iron 3, let's name the SO4. So if you remember looking at the paper, let's go back to the paper and look. SO4 is what? What's SO4 is? He's sulfate, right? What do polyatomics do? They keep their name. So all you got to do is write iron 3 sulfate. Okay? There's a couple things I have to go over real quick just so you can see. Remember, when we're naming ionic compounds, you have the metal and then the nonmetal, right? The cation and then the anion. The guy who loses the electron, the guy who gains the electron, okay? Now, there's special circumstances when you're naming ionic compounds where you may not necessarily see what's going on because it's not in the formula. Usually you can see everybody's oxidation numbers and everything's nice and easy. But in cases like these guys right here, you can't necessarily see what's going on. So let's take a look with this guy, the ugly element. Get it? Fail, the ugly element. Well, iron here, we got to figure out what's iron's oxidation number. The reason why we have to put their names with Roman numerals is because they're transition metals and they have multiple oxidation numbers, okay? So when we have elements with multiple oxidation numbers, we have to specify what that oxidation number is. But the nonmetals, look at this. Their oxidation numbers never change, okay? Their oxidation numbers never ever change. So we can kind of say the nonmetals never lie. Nonmetals never lie. So real quick, let's look at the nonmetal or polyatomics oxidation numbers. Well, if I go to oxygen, he has a -2 oxidation number, so I can say he has a -2. So let's look right here. Do you see a 2? Because remember, they're supposed to swap and drop. They're supposed to give each other the numbers, right? Now, do you see a 2 right here? No, you don't, right? So what is the only thing that can cancel out a 2? A -2, right? What's the only thing that can cancel out a -2? Only a +2 can cancel out a -2, right? So what happened was, iron had a +2, oxygen had a -2, and they canceled each other out, right? They canceled each other out. Therefore, we see this as just FeO. So you got to pay attention. What happened with the oxidation numbers? Because I know oxygen is a -2. The only thing that can cancel out a -2 is a +2. So that means this has to be iron. That's a 2. So the correctly named, remember the first guy keeps his name. So to correctly name this, it's iron. He's a transition metal. So what's his oxidation number? Well, we figured out the only way to cancel out a -2 is a +2. So he's iron 2. Oxygen, single element, takes an "ide" ending, oxide, right? Now, same thing with this guy. It happens with polyatomics also, okay? We got to figure out iron's oxidation number so we can name him. He's a transition metal. I know he's going to be iron, but I need an oxidation number, okay? Remember, the nonmetals never lie. So let's look up this polyatomic. Let's go to your polyatomic ion sheet. So you see that he is sulfate, right? And if you look up sulfate, oh, by the way, you already know that polyatomics keep their name. So you know this guy is going to be sulfate, right? We just need an oxidation number for iron. Well, we know if you look up at that polyatomic sheet that sulfate has this -2 oxidation number here, right? Do you see a 2 right here when they swap and drop? No, you don't see that 2 right there. So what's the only thing that can get rid of a -2? A +2, right? The only thing that can get rid of a -2 is a +2. Nonmetals or polyatomics don't lie. So that means this one is also iron 2 oxide. So always pay attention when you look at a compound, look at that nonmetal's oxidation number. If you don't see his oxidation number sitting right here in the front, if you don't see his oxidation number sitting right here, that means that oxidation number got canceled out. So you got to figure out what got canceled out so you can make the right adjustments. You only have to worry about this with transition metals. So I hope this helps you a lot, and have a great day.